Next, we are going to discuss the standard deviation. So already we know that mean deviation means that is measures of dispersion we discussed. So what are those measures of dispersion here? Range and quartile deviation and mean deviation. So here range we discussed and quartile deviation and mean deviation we discussed. So here now we are going to discuss that standard deviation. Standard deviation means here the deviation, it is also similar to mean deviation. So what we got calculated in mean deviation? In mean deviation, we got calculated what is the variance, means variation between the items from the mean. So that we discussed in mean deviation. So similarly, the standard deviation is also similar to that mean deviation. Here also we are going to discuss that deviation of the observations from the mean. So from the all the observations means here the observations from what is that any interval the observations may be there. So for that purpose, so what is the mean of the total observation and what is the deviation from that mean to the individual observations will get here in the standard deviation. Why? Because what is the risk involved in that distribution? So means how that variated from the mean. So that must be a risk, means we got calculated the mean. So to identify the difference between that observation to the mean, that that contributes the risk items. So for that purpose to calculate that risk terms, so we are going to calculate in business. We are considering it is in business examples to calculate that what is the risk, means what is the mean. We got one mean, then observation may be different. So what is that? What is the variation between that mean to that individual observations? We are calculating this standard deviation. So to calculate the standard deviation, we can means we can show it the standard deviation. We can show it as the sigma. So to calculate this sigma, what is the formula? Under root of xi minus mu whole square by n. Xi is nothing but individual observation. This is what is that? Individual observation. Individual observation. Next, coming to the mean, mu is equals to mean. Okay, mean of that particular example. So mean, and this is number of items, that is n is equals to number of observations. So here from this we can calculate that sigma is equals to under root xi minus mu whole square by n. We can calculate that standard deviation. So here variance is equals to sigma square, that is without root, that is xi minus mu whole square by n, that is the variance. When we got calculated that root of variance is nothing but that sigma, that is the standard deviation. Standard deviation sigma is equals to under root of variance. That variance is sigma square is equals to xi minus mu whole square by n. So here we got the means, even in case we got the root of this variance, then we will get this total formula of this particular standard deviation. Now we are going to discuss the problem. Now we are considering one example, that is x is equals to the individual observations. What is that? 20, 15, 19, 24, 16, 14. That is total 6 observations we have. So for that purpose, what is the formula for our, what is that? Sigma is equals to under root x minus mu whole square by n, that is a formula for standard deviation. So to calculate this formula, first of all, what is that? What we have to calculate here? X minus mu we have to calculate. To calculate that, first we have to calculate that mu value. Mu is equals to, that is mean. Mean is equals to what is that? Individual total observations by number of items, that is 18. So already we calculated here, that is mean is equals to total observation 20 plus 15 plus 19 plus 24 plus 16 plus 14, then we will get 108, that is the total number of items, means total number of value, sum of this value, then sum of this value by individual, means number of items, that is mean, that is equals to 108 by 6, that is equals to 18 we got calculated. So 18 is the mean, then we have to do, that is individual observations minus mean value, that is 20 minus 18, that is equals to 2, then 15 minus 18, that is equals to minus 3, 19 minus 18, that is equals to 1. 24 minus 18, that is equals to 6. 16 minus 18, that is equals to minus 2. Next 14 minus 18, that is equals to minus 4. Then what we have to do here? Then x minus mu whole square. So here what we got values 2, minus 3, 1, 6, minus 2, minus 4. Then we have to calculate this square of these items. That is equals to 2 square, that is equals to 4, minus 3 square, 6, 1 square, 1, 6 square, that is 6. Next 2 square, 4, 4 square, 16. Then what is that sum of this item? Sigma of x minus mu whole square is equals to 16 plus 4, 20 plus 36. 20 plus 36, 56. 56 plus 1, 57 plus 10, 67. So 6 plus 4, 10, 11. 11 plus 20. 11 plus 20, 31 plus 36. That is 67. So that is x minus mu whole square is equals to 67. Then we are going to apply this some value into the problem of standard deviation. That is sigma is equals to x minus mu whole square, that is equals to 67 by, what is this 67 by? What is that 67 by number of items? How many items? 6. 67 by 6, that is under root. Then sigma is equals to 11.6. That is the answer. That is the standard deviation of this particular example. Okay. Then sigma is equals to, that is 67 by 6. Then sigma square is equals to 11.6 under root. That is only 6, x minus 67 by 6. That is 11.6. Then sigma square. Then we have to remove this square. Then sigma is equals to under root 11.6 is equals to 3.42 answer. Then to avoid this inconvenience, and we can calculate this problem in different way, that is equals to sigma is equals to, we can modulate this particular problem, this particular item. So here we can calculate this sigma xi whole square minus sigma xi by n, sigma xi whole square by n whole, that is equals to whole by n. Then we can calculate this problem with this similar example also. So we'll try for this example. Now similarly, the next formula for to calculate the standard deviation, that is equal to sigma is equals to, what is the formula here? Under root sigma xi square minus sigma xi whole square by n whole by n. So that is the formula. So with the help of this formula, we have to calculate this previous example, that is x items, the observations are 20, 15, 19, 24, 16 and 14. So here what is the total? So that is equals to sigma x is equals to sigma xi is equals to, that is 108. Then here sigma xi square. So here what we need, sigma xi square and xi. So already we got calculated sigma xi. To calculate this sigma xi square, first of all we have to calculate this xi square. So xi square, then first one 20 square is equals to 400, 15 square 225, 19 square 361, 24 square 576 and 16 square 256 and 14 square 14 into 14 196. So that is summation of these total squares, that is 400 plus 225 plus 361 plus 576 plus 256 plus 196, that is equals to total sigma xi square is equals to 2014. So here we have to substitute these values into this formula, that is sigma is equals to, this sigma is equal to sigma xi square minus sigma xi whole square by n whole by n. Then sigma xi square already we got calculated here 2014. Then sigma xi, that is 108, and n is equals to total number of observations 1, 2, 3, 4, 5, 6. 6 observations we got calculated. Here sigma is equals to sigma xi square, that is 2014 minus sigma xi, that is 108 whole square by n is equals to 6. Then whole by n, and that is equals to n is equals to 6. Next, to simplify this, 2014 minus 108 square, that is 11,664 by 6. Then whole by 6. Then to make the LCM, that is 2014 into 6, that is 12,084 minus 11,664 by 6. By 6, the total item of this 12,084 minus 11,664 by 6 is nothing but 70. Then 70 by 6. 70 by 6, that is 11.67, that is 3.42. What we got calculated with the help of our earlier formula, that is equals to sigma is equals to what is that? The root x minus xi minus mu whole square by n. So with these two formulas, we can calculate this standard deviation. According to the situation, we can apply any one of these two formulas. Okay. One more method for to calculate the standard deviation, if the class interval has given. So here the example of this particular problem, consider this example. First one, first the marks of particular students and particular class students and the frequency. So here the marks in between 0 to 10, 1 student, 10 to 20, 3 students, 20 to 36 students, 30 to 40, 10 students, 40 to 50, 12, 50 to 60, 11, 60 to 76, 70 to 83 students, 80 to 92 students, 90 to 100, 1 student got the marks. The total strength of the class, that is equals to 55, that is total frequency. So here that if that this problem has given how to calculate the standard deviation of this problem when we got the class interval example. So for this purpose, here we have the formula to calculate the standard deviation when the class interval has given. So that is sigma is equals to c into under root of I is equals to 1 to k fi di square by n minus sigma I is equals to 1 to k f di fi di fi di, that is sigma I is equals to 1 to k fi di by n whole square. Here fi di square, here fi di by n whole square. So that we whole square, that is this is the formula where the c is c indicates that is the width of the class interval, means the difference between the first observation to that next observation, that is the width of that class interval is nothing but c. So here fi di means f is the frequency of that particular class interval when we got that assumed frequency. Here we are going to select. So for this purpose, we have to calculate, what means to substitute the values into the formula, we have to calculate fi di square and fi di whole square. So to calculate this one, first of all, we have to calculate the midpoint of the class interval. Here the class intervals we have here, we want 0 to 10, 10 to 20, 20 to 30, up to 90 to 100. So what is the midpoint of this class interval? That is 0 to 10. That is midpoint of this class interval 5. Then 10 to 20, midpoint of class interval 15. 20 to 30, midpoint of this class interval, that is 20 plus 30, 50 by 2, 25. Next 30 plus 40, 70 to 70 by 2, that is 35. Then 40 plus 50, 40 plus 50, 90 by 2, that is 45. 50 plus 60, 110 by 2, that is 55. 60 plus 70 means 130 by 2, that is 65. 72 plus 70 plus 80, 150 by 2, that is 75. 80 to 90, 170 by 2, that is 85. 90 to 100, 180 by 2, that is 95. So that is midpoints we have to calculate of this particular all class intervals. Then after making this midpoints, after calculating this midpoints, what we have to do? Deviation we have to calculate. So here we have to calculate deviation, means we have to calculate the deviation by 10. So for this purpose, we have to calculate this deviation, means we have to select one mean, means any one mean we have to take here. That is, we have to assume that mean. So here what is the mean of this? Any mean we can take, that is 0 to 100, any mean value we can take. So here we are assuming that 55 is our mean value. 55 we are taking that deviation mean. So for that purpose, what we have to do? That is the deviation by 100, means 55 minus 5 by 100. So here we have to calculate what here 55 and it means 5 minus 55, that is 5 minus 55 by 10, that is 5 minus 55, that is minus 50 by 10, that is minus 5. Similarly 15 minus 55 by 10, that is 15 minus 55, that is minus 40 by 10, minus 4. Similarly 25 minus 55 by 10, that is 25 minus 55, minus 30 by 10, minus 3. Similarly 35 minus 55 by 2, sorry 10. So 35 minus 55, that is minus 20 by 10, that is minus 2. Here 45 minus 55 by 10, that is minus 10 by 10, minus 1. Here 55 minus 55 by 10, simple 0. Here 65 minus 55 by 10, 65 minus 55, 10, 10 by 10, 1. Here similarly 75 minus 55 by 10, that is 20 by 10, 2. Then 85 minus 55, that is 30 by 10, 3. Then similarly 95 minus 55 by 10, that is a deviation, means what we have taken here, d by 10, means d is nothing but what, deviation from the mean. So that is 5 minus 55 we have taken as the mean value. So 5 minus 55, that is a deviation from the mean, that is d by 10. Then we are calculating this deviations. So that is minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. So after getting these deviations from the mean values, then we have to calculate frequency into d dash. Frequency into here we got calculated d dash, that is d by 10. D means deviation from the mean. Deviation from the means means we have to assume one mean value from the means. So that mean value we should deduct from the individual midpoint of this class interval, that is 5 minus 55 by 10. Similarly all the deviations we have to calculate, then we will get the d bar. Then after getting the d dash, f into d dash, that is frequency into d dash. What is the frequency here? 1 into 5 minus 5, minus 5, 3 into minus 4, minus 12, then 6 into minus 3, 6 3s are minus 18, next 10 into minus 2, 10 into minus 2, minus 20, 12 into minus 1, minus 12, 0 into 11, 0, then 6 into 1, 6 ones are 6, next 3 into 2, 3 twos are 6, next 2 threes are 6, next 1 fours are 4. Then here we got all the values of f into frequency into d dash. Then after that d dash square into frequency. D dash square, what is the d dash? 5. 5 square, how much it is? 5 minus 5 into minus 5, 25. That is 25 minus 5 into minus 5, 25 into 1. That is 25. Then similarly here d dash we have to square this d dash. So d dash is equals to minus 4. Minus 4 square. Minus 4 square is equals to 16. So 16 into 3, that is 48. 16 into 3, 48. Next minus 3 square. 9 into 6. How much it is? 54. Next minus 2 square. 4 into 10, 40. Minus 1 square, that is 1 into, what is that? 12, 12. Then 0 means there is no 0, 0 as it is. Then 1 into 1 square, 1 into 6, 6. 2 square, 2 into 4 plus into 3, 4 into 3, 12. Then 3 square, 9 into 2, 18. Then 4 square, 16 into 1, 16. That is fi di bar square. So that total summations we have to calculate fd bar, fd dash and fd dash square. That is total fd dash means summation of this fd dash, that is what, minus 45, here 231. So simply we have to substitute all these values into this formula, that is sigma is equals to c into sigma I is equals to 1 to k fi di square, then minus sigma I is equals to 1 to k fi di by n whole square. So here what is this value? Fi di square, fi di square, that is 231. So first 231 by n, that is frequency, observations, n is equals to 55. Then 231 by 55. C is nothing but width of class interval. Width of class interval, how much it is? 0 to 10, 10 to 20, 10 to 2. Means what is the difference between this lower observation and higher observation? That is 10, 10, 10, 10, 10. So that width we have to consider as a C, width of class interval. So further purpose, sigma is equals to 10 into, so fi di square. Already we got fi di square. The sigma of this means summation of this fi di square. that is 231. 231 by sigma n means f sigma f, that is equal to n is equals to 55, minus then sigma I is equals to 1 to k fi di square, fi di by n whole square. So what is sigma I is equals to 1 to n 1 to k fi di, that is f d dash, f d dash here, f d dash, f d dash how much it is, minus 45, minus 45 by 55, that is n is equals to 55. Then 10 into, then to simplify this root value, then we will get this 10 into 231 by 55, 4.2 minus 45 square, 40 minus 45 by 55, then we got some 0.066942 that we have to square it, then we will get 0.66 value. Then after to simplify these values, we will get this 18.8 marks, that is the standard deviation of this particular observation. This particular marks class is nothing but 18.8 marks, that is the standard deviation. Okay, so